3C, name the degree of counterclockwise rotation from point X to the given point. So this is our pre-image. We're beginning at X, and we want to know how many degrees it takes counterclockwise to map to the image D. So we always begin these problems, and this one's come up a lot. We begin with the good old 360. You write 360 down. You decide, how many congruent parts does my figure have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's got 8 congruent parts. We know each time we rotate from congruent part to congruent part, we're rotating 45 degrees. Oh, you did clockwise. Okay, no problem. So we do 1, 2, 3, 4, 5, 6. 45 times 6. Number 5, first of all, it says, what types of symmetry does this figure have? Let's name this figure. Let's give it a name. What is KLNPR? It is not just any old pentagon, though. It's a regular pentagon. Cool. When we have a regular polygon, it's actually going to have line symmetry and rotational symmetry. Reflectional symmetry and rotational symmetry. So you can call that first one line symmetry or reflectional symmetry. Doesn't matter. Oh, what about the extra extensions of the thingy? Those are just the exterior angles drawn. Those don't hurt anything. Those shouldn't hurt it. Yeah. Those are just an extension of the line showing the exterior angles of the polygon. Yeah. And look, they all have double tick marks on them, so they're all congruent, keeping it nice and symmetrical. Yeah, so this one has reflectional and rotational symmetry. It's 5-sided regular polygon, so 5 lines of symmetry, and then the angles of rotation, good old 360 divided by the number of congruent parts, or vertices in this case. So you're going to write 72, and then your next angle of rotation would be 72 times 2. Degrees on here to be playing by the rules. 72 times 3. 72 times 4. What's going to happen if I do 72 times 5? We'll end up at 360. Do not write 360. That's not an angle of rotation. That doesn't count because then you're back where you started.